Today I'm going to talk to you about commuting magnitude and direction of a 2D vector. First, we're going to talk about definitions. Our first definition we need to learn today is magnitude. Magnitude is the length of the line segment from the origin to the end of the vector. You're going to compute this by solving for the radius. R2 equals x squared plus y squared. To find r by itself, it'd be r equals x squared, or the square root of x squared plus y squared. Our other term we need to learn is direction. Direction is the angle the line forms with the x-axis. So direction in quadrants 1 and 2, you need to use tangent. So on this graph, I have my line at 3, 3, and then I'm going to use a tangent formula. Tangent, the angle of tangent of theta is y over x. For this example, tangent of theta equals 3 over 3. Tangent of theta equals 1, and then therefore the angle measurement is going to be pi 4. In quadrant 2, it's a little different. We're going to use cosine. So here on my graph, my point is at negative 1, 1. Cosine is x over r, where r is the radius, and the radius for this graph is 2. For this example, cosine equals x over r. Cosine of theta equals negative 1/2, which therefore makes cosine of theta 2 pi over 3. How did I go from negative 1/2 to 2 pi over 3? I used the unit circle, and wherever negative 1/2 was x on the unit circle, that would be our new cosine angle measurement. The third quadrant is just a little bit harder. There are going to be 2 steps. So the first step is to compute the direction for the parallel in quadrant 1. Because in quadrant 1, and then this is your original one, quadrant 1 and them, they're the exact same, but they're just parallel. And you would do that by adding pi radians or 180 degrees. So as you can see over here on mine, my original point was negative 3, negative 3. But I added 180 degrees, which then got me my new parallel, which is positive 3, positive 3. For this equation, you're going to use the tangent inverse, which is y over x. For this example, tan of the inverse equals 3 over 3. And then theta equals arctan of 1. And then theta now equals, you'd add the pi radians, so it would be pi plus arctan of 1.